Hello and welcome to Friday's edition of Cracking the Cryptic and a brand new puzzle, literally brand new, from Bastien Vial-Jaime, the genius from France. It's called Weather Vanes, and he says he's obviously made it very colourful at the start in order to cheer everyone up given what the world's going through at the moment. But apparently the colours are unnecessary for the solve, so I might get rid of them, but I just want to admire the construction before I do that. Just look at how beautiful this puzzle is. Symmetrically disposed killer cages, symmetrically arranged sort of lines joining these circles in the grid. I mean, it is just a beautiful looking construction, and it's what we've come to expect from Bastien. He is just a setter most extraordinary, and yeah, I'll read you the rules in a second. They are quite interesting. We've got a between lines constraint today, which we don't see very often. Before we get started, a couple of things to mention. I wanted to share something with you I found on Twitter today. So if you don't follow us on Twitter, we're at Cryptic Cracking. And the poet Brian Bilston, who I'm a massive fan of, and he wrote the poem called Refugees. And if you've never read that, I definitely recommend it to you. That is some sort of work of genius, because you read it forwards and it seems to mean one thing, and then you read it in reverse, starting at the bottom and going upwards, and it means the opposite. I kid you not. That sounds ridiculous, but it is true. Anyway, he published this one on Twitter today, monetization. So the advert said, monetize your followers, so he thought he would respond by painting them in the changing light like water lilies in a pond, which is lovely. And it's sort of, you sort of read it and you think, well, the language is lovely, but what does it really mean? And it's just a brilliant play on words, because if you realise that monetize could be read instead as monetize, then all of this reference to water lilies starts to make sense. And I just found it very, very amusing, and I thought therefore I would share it with you. Forgive me if it's not your cup of tea. What else do I want to mention? Well, we're coming up fast to the 1st of February, when we will be publishing our bonus monthly puzzle on Patreon. So if you're a patron of the channel, look out for that. I can tell you that it's not just one puzzle this month, it's a whole series. So we've got something quite special for you that we hope you'll enjoy. Now let's get on to Bastien's puzzle. Maybe I should get rid of the colour now. I'm a bit loath to do it, but I will. There we go. It looks quite plain, except we can still admire the geometry. Now the rules. Normal Sudoku rules apply. In cages, digits sum to the small value in the top left corner of the cage, and digits cannot repeat within a cage. Digits on a line must be strictly smaller than one of the two corresponding circled digits, and strictly larger than the other. So this is the so-called between lines constraint. So if we look down here, if we make that a 2 and that a 7, what we're saying is that along this line, the digits have to lie between 2 and 7. So you can't now put a 2 on the line, you can't put a 1 on the line, you can't put an 8 on the line or a 9 on the line. You've got to make sure these digits, they can be in any order, but they just have to lie between. That's not going to work, is it? That would work. So that sort of arrangement is a perfectly valid arrangement of these two circles and the line between them. So I've not done terribly many puzzles like this. I hope that I will be able to show you some sort of logic to get you through this one. Do give it a go yourselves. I really cannot recommend Bastien's puzzles highly enough, or too highly. And I'm absolutely delighted to tell you that our upcoming Arrow Sudoku app will feature Bastien's puzzles, which is marvellous. And Fistomerfeld's puzzles as well. Also marvellous. Yeah. And Christoph's, and Prasanna's, and Sam's, and Richard Stolk, yeah, and Codec. Yeah, I'm not joking. It's all good, isn't it? It's all good. Anyway, let's get on with this one. The way to play is to click the link under the video. Now I get to play. Let's get cracking. And the first thing that strikes me is we've got 1s, 2s, 3s, and 4s in those 10 cages. Now, does that mean something to us? It means that Okay, well it means the 9 in box 1 gets pushed over here. Because a bit like thermometers, you can never put a 1 or a 9 on a between line, because then if you did, you'd have to put 0 or 10 in the circles, and 0 and 10 are not valid Sudoku entries. So given we can't put 9 in those two squares, we must put 9 in one of those positions. Which, does that matter? Okay, yeah, so that pinches the 9 in box 7. Look, you can't put 9 here by Sudoku. You can't put 9 in a 12 cage. And you can't put 9 on the line. So 9 goes in that domino there. 9. This trails round the grid, look. So now we can't put 9 here. We can't put it on a line. We can't put it in a 10 cage. 9 goes here. And a 28 cage in 4 cells, that has to have a 9 in it, because, well, if you add up 8 plus 7 plus 6 plus 5, you only get 26. So there we get a digit straight away. 9 goes in here. The other thing we know actually about 28 in 4 cells is it must also have an 8 in it. Does that mean anything? So that means there's an 8 in one of these 3 squares. I'll pencil mark that. So the 8 is in one of 3 positions. The 8 can go on the line because the 9 is obviously higher than that. Good Lord. Right, okay. So we have a small start. What does our start mean? A 12 cage down here, that's in 4 cells, that must have a 1 and a 2 in it. So there's something going on in the perimeter, look. You couldn't have the 1 and the 2 in both of those cells because you couldn't put 1 and 2 into this cell. This cell, no cell is a Schrödinger cell. It can't be 2 things at the same time. So there's no 1 and 2 here, so there must be... But you could have 1 and 2 this way. That would push 1 and 2 into these 2 cells. Okay, I'm not sure I'm thinking about this quite the right way. 9. So what can go on the line here? The line... Oh yeah, okay. So maybe actually a better way to think about these circles is to think about them in terms of which is the low circle and which is the high circle, because you can see that these 2 cells here have to be higher than 4. Yeah, they do. They have to be higher than 4 because 1, 2, and 3, 1, 2, 3, and 4 are in the quadruple there. So these squares have to be 5, 6, 7, or 8. Which means this is the low circle and this is the high circle. Right, okay, but there's a bit of a... yeah, this is interesting. This is a good way to think about it, because now the minimum I can make these 2 squares, this domino cannot be filled with digits that are smaller than a 5, 6 pair. So this has to be higher than 6, which means it... It can't be 9, actually. I was about to say it's got to be 7, 8, or 9, but it can't be 9. So this has to be 7 or 8. Which means that these can't be 8 anymore. Once this can't be 9, these can't be 8. So 8 in box 1 is now over on this side as well. Oh, that's lovely. Right, this square can't be 8 or 9, because via the medium of the 17 cage, it will break. If this is a 7 or an 8, if that's 8, that will be a 7. That will add up to 15. This would have to be double 1 to make the 17 total. You can't put double 1 in a cage. And if it's 9, it's even worse. You'd have to make this 1, 0, which won't work. So this square is just not 8 or 9, which means these 2 squares are 8 and 9. And there is a peculiar little pair in box 1. So this can be 7, because then this could be 5, 6, and this is essentially a free cell, because this could go right back to being 1, 2, 3, or 4. Hang on a minute. I'm being very, very slow here. Right. Stop being slow and start being sensible and use the thing called Sudoku to help you. I know I tried not to do it, but I am going to resort to Sudoku now. Where do we put whatever goes in this cell in box 1? The answer is I don't know, but it definitely... In fact, I do know. I do know because it can't repeat. The 7 can't go in this cell. Oh, God, I'm sorry, I'm being appalling here. 7 can't go in this cell because if you put 7 in this cell, where do you put it in box 1? The answer is nowhere. You now can't put it in any of those cells or these 2 cells, and you can't put it here because it will repeat in the cage. So this just is an 8. And now look, you've got 8s here and here, and now this square is the only place an 8 can go in box 7. So that's 8. This is 9. And that's not 8 now. Oh, in fact, look, where does 8 go in our 28 cage? It's only got one position it can go in. It's got to go here. And now where does 8 go in box 9? It must go here. Oh, this is cheering me up in the middle of lockdown, Bastien. This is very good. Even if I was cross with myself for the start and not spotting this stuff very quickly. Now... So 8's now down there in box 8. Right, here's some nice logic. The 23 cage now has not got an 8 in it because of these 8s. What would happen if it didn't have a 9 in it? Well, then the highest digits we could put into it would be 6, 7 plus 6 plus 5 plus 4, which only add to 22. 22 is not equal to 23, so there is a 9 in the 23 cage. Where does the 9 go? It's only got one position by our old friend Sudoku again, so 9's go into the grid. Now what? So now... We have got a 9 in here. These squares have got to add up to 14. That means nothing to me. Vienna. We've got... So this square's got to be a 5, 6 or a 7. Oh, but I suppose this can't be a 5 because then I can't make this square lower, and these lines are joined by a weather vane as well. So that's not 5, and similarly that's not 7. And this just can't be 7 anyway, because then we run into the double 1 problem. Anyway, sorry, I forgot about the double 1 problem. If you put 7 here, you get 15 in the cage, and those have to be double 1. This just is 6, so this is 5. This is 7. This is a 1-2 pair to make 17. This cell is not 1 or 2, therefore. So the 1 and the 2 are getting squeezed in the 12 cage. Oh, in fact, yeah, let's just think about that for a second. We know that this is not a 1-2 pair because it breaks this 10 cage. So this cell simply is a 1 or a 2. Now, yeah, okay, and now we can ask the question where 7 goes in box 7. Because 7 can't go here by Sudoku, it can't go in the 12 cage. So it's got an option of 2 cells, but if I put it here, this cell would have to be, well, one of these 2 cells would have to be higher than 7. And there's no option available because the 8 and 9 have gone from the box. So the 7 goes here, and it can't go in the 12 cage. 7 is on the left-hand side of box 4. 7 Sudoku gives us the 7 in box 9. Oh, that probably puts pressure on the... Yes, it does put pressure on the 28 cage, because how can we make that? We need those two squares to add up to 11 without using 2, 9, 3, 8 or 4, 7 now. That's a 5, 6 pair all of a sudden. And oh, lovely. And now we can sort of use the thermometer type property of this 5, 6 pair to know this square can't be the higher of the two digits, because then we won't have these two cells sort of being the sandwich. So this must be 6, this must be 5, this is therefore 5. There's a 5, 8, 9 triple in both of these boxes. So these squares are 5, 8 and 9. That's not 5. We're doing quite well for a change. These squares are 1, 2, 3 and 4. Oh, we know, look, we know more than I thought we knew. We've got 16 already in the 23 cage. So these two squares have got to add up to 7. And the options available are, well, we can only do it with 3 and 4. So we get the 3 and the 4. We get a 1, 2 pair here. This between line is completed. This... there must be a 7 down there by Sudoku. I must know what this 12 cage is now, do I? This 12 cage is either 1, 2, 3, 6 or 1, 2, 4, 5. I'm sure I know what it is if I was clever enough to work it out, but I can't see how to do that. I've got 3, 4 and 5 to place in this column. Let's have a think about that. So this cannot be 3 because then this will be higher, and that's the wrong way round. Therefore this can't be 5. Ah. Hang on. One of the digits in the 12 cage has to be a 5 or a 6. And now that cell cannot be a 5 or a 6 because this square would therefore be lower than it. So the 5 or the 6 in the 12 cage must lie in the corner, I think, which means this square must be a 1 or a 2. Because a 12 cage always has a 1 and a 2 in it, and there are only 2 cells the 1 and the 2 can go in. Ah, okay, so that gives us a useless quadruple in column 1. Oh, bobbins, that's annoying. Look, 9 can go in one of those 2 cells. I still don't think I can work out how to figure out which way round this 12 cage goes. I've now got a 1, 2, 3, 4 quadruple in row 9 as well. But again, it doesn't really do anything because whichever of the 5 and 6 is not used will just shift over here where it's unrestricted. Sorry about this, I'm a bit stuck. What do I do here? Have we got... these squares have got to be 1, 2, 3 and 4. Whoa, I don't want that pencil marking. I want that pencil marking. Ah, that's interesting. So again, I think we get something interesting by considering, yeah, which is the high and which is the low digit. In all of these squares, actually, this square can't be a 1 because it's on the line. Now, if this square was a 5 now, I would break this square, wouldn't I? Because if this is a 5, these 3 squares, because this is a 2, 3 or a 4, these 3 squares have to be lower than 5, which would make this square have to be a 1, and you get a 1, 2, 3, 4, 5 quintuple in these yellow squares, which gives this no option. So this is not 5. This is 5. 8, 9 pair in row 2. What does that mean? Oh, 7. Where does 7 go in box 3? You can't put it in the 20 cage because it'll join its friend the 5, and even if I make that an 8, that triple will already add to 20 without using that cell. So 7 can't go on here because of that 7, so the 7 goes here. This can't be 4 either, can it? Sorry, I'm being a bit slow here, but we've got... If this was 4, one of these two squares would have to be higher than 4, and neither can be. So this square is actually quite low, and therefore the low boundary has to be even lower than whatever goes in this square. So this square is a 1 or a 2. And that nearly creates a quadruple in the row, and 6 has to go in one of those two squares. If 6 was in the 20 cage, it could work just. If this is 8 and this is 1, now what? We can say that what have I not used yet? I've not used 14 cage, is that? Oh yes, it is. Oh, that's beautiful. That's beautiful. Okay, let's look at the 14 cage and note that there is a 5, 6 and 7 that cannot go in the 14 cage. So, if the 14 cage contained no digit higher than a 5, it would have to be a 1, 2, 3, 4 quadruple. 1, 2, 3, 4 quadruple only adds up to 10. So there must be a higher digit in the 14 cage, but that digit cannot be 5, 6 or 7, so it has to be 8 or 9. But you can't put 9 in a 14 cage because the minimum you could make 4 cells add up to would then be 15. So there is an 8 in this domino. That is lovely. That in fact gives us a digit or 2 as well. 8, 9, 8, 9. 9 in one of 2 positions in box 2. This, yeah, okay, the 14 cage, once you know it has an 8 in it, it's 1, 2, 3, 8. So that's not 4. These squares here are 1, 2, 3 or 8. Now does that resolve anything? It tells us that... I'm not sure what it tells us yet. 13... This domino has to add up to 7, and it can't use 2, 5 because 5's gone. So this square can't be a 2 anymore because you'd have to repeat the 5 in the cage. So the options for this domino are 1, 6 or 3, 4 in some combination. 6, 3, 4, 6. Ah, lovely, lovely. You can't put 3 in here. If you put 3 in here, which one of these do you make higher than 3? Well, there's only one that can be. It would have to be that one. But that means these two are adding up to 7, which doubles the 3 in the box. That doesn't work. This square can't be 3, therefore it is 2. That gives us the 1. This square is now a 3 because it sees 1 in its cage and 2 in its box. So these become a 2, 8 pair. This is not 2 or 3 anymore. 1 is not here, 2 is not here. We can now do the ordering of this between line because the 3 is the high digit, so the 1 must be the low digit. Therefore this is a 6 because we know the domino adds to 7, and that's a 4. And we're cooking with a bit of gas. 1 in the 10 cage can only go there. That fixes the 2 and the 1 in the 12 cage. 1 is not in those cells anymore. That's not 2. And that's not 4, look. These aren't 1. I think I've got to be a bit slower here and just try and tidy up some of this stuff. So 3 is not... So this becomes a 2-4 pair. There's a 2 down there, so we know the order. 2 and 4 go in. Still don't know what this 12 gauge is. I've got a feeling you're all shouting at me. I'm really sorry if it's obvious. This is a 5-6 pair. This square we can write in. That's a 4 by Sudoku. Look, let's not neglect Sudoku. That gives us a 4 and a 3. 3 must be in this domino here. We need 3, 7 and 9 to complete the box. Let's put that in. We know that's not 3. We know that's not 9 by Sudoku. So this square's a right in. That's a 4. Oh, look, 4 in box 4 is restricted now. It's got to be in one of those 2 cells. And that means we get the 4 in box 5. We've not placed 1, 2 and 3 in this. Oh, I see, look. You can't put 1 on the line, ever. So 1 doesn't go on the line. Oh, this is completely resolved. Column 8 is completely resolved. You have to put the 1 at the top, because the 1 can't go in either of those 2 cells. Actually, let's just figure out this side of the grid and see if we can get any more joy. We might be able to. But I think the point here is this now acts like a thermometer again. So if we put the 3 here, then the 2 will be on the line and lower than the 3, which doesn't work. So you've got to go 2, 3 like that. That's therefore a 1. We can remove the 2 from here, the 1 from here. We get a 3, 4 pair. No, it still doesn't resolve. Oh, come on, Simon. This square's a 2. That's a 2, that's an 8. 8 doesn't live in this cell anymore. 2's in one of those cells. These squares, we know what they are. They are 2, 6 and 7. Okay, I don't know what the order is yet, but I know that's not 2. I have a feeling I'm missing something really obvious here. 3, 4 and 6 into this column. So let's have a look at this. We can at least limit some of these squares. This square is not 4. This square is not 3. This square is... it's got to be higher than 2. It always will be. Bobbins. Oh, 3, look, by Sudoku. Don't forget Sudoku. These 3's. Pinch the 3 into this square. That means that's not a 3. This is not a 3. Oh, we get the 3 finally in box 7. It has to go there. That gives us the 3 and the 4. The 12 gauge now tells we actually finally know what this 12 gauge is. We've got 6. That must be a 6. That's a 4. That's a 5. That's a 4. That's a 6. Goodness. Actually, this is nice now. We might be getting towards the home straight. We need 5, 7 and 9 to complete the box. We don't have... That square's a 7. Get rid of the 6 here, the 7 here. And okay, so where do we go now? I've got to put 1. This is a 1, 6 pair. I can never put 1 on the line so that we actually know the order. It goes like this. That fixes the 6 and the 5 at the top. 5, 7, 8 at the bottom. Don't know the order of that yet. What do we know now? 3 by Sudoku goes there. This has to be a 2 or a 6 to complete row 5. It can't be 6, so it's a 2. That's a 6. That's a 7. That's a 2. Has that figured things out for us? The answer... this 3 is helpful. That gives us 7, 9 at the top. Yeah, I think this might be... We might be on the home straight. Get rid of the 7 from the bottom. Can't do the 5 and the 9 yet. But I think we've done all the complexity, so it literally is just filling in the rest of the grid, hopefully using the power of Sudoku to help us. These are 5, 7, and well, the 1, we can do the 1, let's do the 1. And then I'm going to switch tack and look at the 7 and the 8. The 7 here tells us the order. 8, 7, 5, 8. These two squares are 5 and 6. We can do those using the 6 here. These two squares are 7 and 9. We can do those. The 9 and the 5 go in. Let's make sure we put the right digits in. And that is how to solve a beautiful Sudoku puzzle by Bastien. As usual, it's no surprise, but it really is classy setting, isn't it? The way these funny lines interact is most peculiar. I definitely have not got my head around them yet. Please don't take that as an invitation to create lots of monstrous between line puzzles. But yeah, it's just beautiful. A beautiful puzzle, beautiful geometry, and I really hope you enjoyed it. Do let me know in the comments. I do read them, and we'll be back later with another edition of Cracking the Cryptic.